For the secure software development module, we were supposed to identify vulnerabilities in an application that we choose. So we have chosen CleanPath, an application that we built to check these vulnerabilities, and we have identified 7 of them, and we will be addressing these throughout these videos, how we fix them as well. Even the OAuth connection flow will be addressed. Starting off with my part, I found is IDOR, in other words, insecure direct object reference vulnerability. Here, a regular user can delete another user just by changing the ID because authorization checks were missing. So when you look at the code, in the function delete user by ID, there is no check to see if the requester owns the account or has admin rights. So I have added some checks in order to do it mainly, and then also did some changes in the auth middleware, and in the user routes I have added the authenticate and authorize admin headers for the route. By this, the IDOR vulnerability was fixed, and in order to fix this, check this, I have written some unit tests. So let me show you the output. As you can see, these are the test results. I'm addressing is cryptographic failures. In this CleanPath project, there were several multiple cryptographic failures, including weak password policies, plain text, credential storage, insufficient authentication controls, and insecure token management. So this left the app open to brute force stolen credentials and brute force attacks and token abuse kind of situations. So I have done some fixes. I'm not going to explain them, but as the test results, you can see that I have fixed the cryptographic failure situation, and with these fixes, passwords are hashed and brute force is limited and tokens are safer. So thank you.
This is all about my part. Thank you. Hello, my name is Ashok. This is my individual platform SSD assignment. I have identified some issue on our selected project, that is identification and authentication failure. In our old project, we can see that there are a lot of sensitive details that are stored in a local storage. As you can see, the tokens and IDs are stored in a local storage. This can be a most critical vulnerability issue. So this can lead to cross-site scripting, and easily attackers can attack our site, our platform. So in order to mitigate that, I have implemented secure storage local storage package. Using this, we can encrypt all the sensitive information of a user and save it in secure way. Then the attacker cannot see anything else. So in order to check the secure storage utility function is working, I have written a test case. As you can see, this there is a no plain text in token and no exposed details of user credentials, and this prevents the access cross-site scripting token attacks. This is regarding the Google authentication or authentication implementation. So in order to do that, first of all, we need to create a Google Cloud Console account and a project. In order to get the client ID and the secret, I have set up the JavaScript origins and URLs. And after that, we need to set up our backend. I have written a file called passport.js. This is for the main file for the authentication. So this checks the Google client ID and the secret from the environment variable file, and it gets and check if the user is registered on our platform. It will automatically sign in him. If not, it will create a new user and it will redirect to his dashboard. So for the front end part, also I have implemented it. And for the demonstration purposes, you can see this user is not registered on our platform, so you need to get his Gmail registered. If the authentication is successful, they will be linked in his dashboard. If they check their profile, they will be added. If they log out and if they can't go, if they want to go into again and their dashboard, they can press simply this continue with Google button. It will automatically authenticate them in each and every time. They don't need to register the system, so it will easily go to their profile. Thank you very much.
Hello, I'm PGRMD Perumboli. In our project, I found two vulnerabilities. First one is CSRF attacks, which means cross-site request forgery. It is a type of attack where is a malicious website triggers a user's browser into making unwanted requests to our server using users' credentials. This can result in unauthorized actions such as changing account details or deleting data. To protect our project from CSRF attacks, we implemented some changes. First, we added the CSURF middleware to the Express backend, which generates unique CSRF token for the each user sessions. Uh, all post, put, and delete requests now require the valid CRS token. And for the front end, we updated the API helper to automatically fetch the CSRF token and include in the headers of all post, put, and delete requests. Uh, for the verification, this fixed, I wrote test cases. You can see the results here. And yeah, the second vulnerability is broken authentication and authorization. The delete endpoint for user deletion in our application was completely unprotected, allowing anyone to delete user accounts without authentication or authorization. We manually figure out that, and for the for then we implemented the solution for that. We authenticates and authorize the delete function. So yeah, for that also I implemented test cases for verification. You can see the results here. Yeah, that's my part of the project. Yeah, thank you.